Thanks to CircleCI for having us, just to keep the thank you train going. We're big fans of the product, and I've been using it since pretty much the beginning, before I was even at Shyp. So yeah, who knows what Shyp is? Everybody here? So real quick, for those who don't, just gonna give the 2-second pitch. Shyp is really just shipping made easy. We have mobile apps where it's as easy as taking a picture and punching in an address to have a courier come to your place, pick it up. We'll then take it to our facility where we professionally pack it for you, and then we price shop and ship it out and make sure that it gets there safe. And we ship internationally, and right now we're shipping out of San Francisco, New York, Los Angeles, and Chicago. So yeah, so today we're gonna do, real quick, before I jump in terms of, since we're all here nerding out, an overview of what kind of tech we have at Shyp. We have 4 mobile apps, both the customer-facing apps, both iOS and Android, and then 2 internal iOS apps represented by those green icons, Compass and Anchor. Compass is for our couriers who run around on the streets and pick things up, and Anchor is an iPad app that we have in our processing facility that helps all of our technicians pack things safely and accurately. We then have an API that supports all of it, and then also on the customer side, we have some web apps. We're using React for the most recent stuff, and we have some legacy Angular that I wrote a long time ago, so which we're trying to get rid of as fast as possible. So anyway, so we're going to do a real quick run through 4 quick topics on how we built a command line interface, and the origins of this command line interface actually stem from using Circle, where we, though we love Circle, we hate waiting, and so we decided to automate waiting. So these are the 4 different topics. Save your questions for the end, because we've got a lot of slides, and we're going to try to get through really fast. So without further ado, Kevin Burke, who was the guy who said, I'm building a CLI.
I'm going to try not to speak in circles up here, but just circle the wagons for a little bit and listen to some talks. All right. Thank you. I'll be here for the next 10 minutes. Okay, so I work on engineering success at Shyp, which is kind of broad, but just like the health of the framework and the health of deploying things to production and making sure that's easy and fast, and making sure that it's sort of pleasant to work day to day on the framework, and pleasant to ship code and all the other stuff that you kind of do as an engineer day to day. Okay, first observation, builds are slow. Slow for me is anything that takes longer than 100 milliseconds. CircleCI builds, even if you just print like OK to the screen, take about 30 to 40 seconds, so they're slow. So yeah, I mean, that's true of anything, right? Like anything's probably going to be slower than 100 milliseconds. But yeah, so waiting for a build, if you're going to be pushing to CircleCI and then waiting, you're probably going to context switch, right? Like you might check Slack or check your phone or whatever, right? Or do something else while you're sort of waiting for your build to finish. But the problem with context switches is that like you have to context switch back to remember that your build succeeded or failed and then do something about it. So that's kind of painful, right? So I wanted to build a thing that like let you know when your build finished, besides just like going in Chrome, because you can lose a tab in Chrome really easily. So I built a command line tool that basically just parsed the current Git branch you were on and then hit the CircleCI API. Also parsed the Git remote, right? And then sort of turned that into a CircleCI request. Got the build status and then sort of kept polling until it was succeeded or failed. And the first version of this was really, really basic, right? It just hooked into Quicksilver and like printed in really big letters to the screen when your build succeeded or failed. So yeah, so this was great, right? Like I could go, on Slack or whatever, and then get notified when things succeeded or things broke, and then take whatever action needed to be taken. So yeah, so that was great. And then I said, okay, well that's great, but like we want to actually see, why this failed and sort of get more information about it, right? So let's sort of move past that. Oh yeah, so figure out why builds failed, right? So the build failed, so now it's like, why did it fail, right? So then the second sort of command I built into this command line tool is just open, right? Which just opens a URL in the browser, right? Like pretty easy, but also like you have to, if you do that manually, you have to go to the CircleCI homepage and then like click through and find your build and wait for it to load and click through, right? If you hit the API, you can just pull the build number straight from there and then go straight to that page, which is neat. It saves, I don't know, 5 minutes a day. So yeah, so that was great. And then I said, well, builds are slow, right? How slow are they, right? Like build speed has a significant impact on how happy we are as a team. So let's make everyone aware of how fast or slow the build is on a given day, and let's let people know. Oh, install took a minute. You know, why does it take a minute? That's a really long time, right? So let's sort of figure that out, right? So then I did more parsing, right? Yeah, so this is the basic thing. If your build got 30 seconds slower, how many minutes and hours did that translate into for your development team? And how would you know, right? Like, unless you're really, really good about it. So yeah, so then I sort of like improved the output a little bit. So it parses all the build steps in CircleCI and prints them to the screen with timings. If they fail, they'll show up in red, which is a neat thing. I'll zoom in on this a little bit. So yeah, so you can see basically how long each of these steps take. And then you can see sort of how it changed over time, right? If you're looking at this every single time you do a build, you're going to start to know, oh, okay, well, the build took 3 minutes yesterday, and it took 3 minutes 45 seconds today. We should go see what went wrong or who wrote a bad database query or whatever, right? So yeah, so that's super neat. This is open source. It's available. If you go to this URL, you can download it. You can run it just circle wait. We'll just wait for builds to finish, and then circle open will open them in a browser. And circle wait, you'll get this nice output, which prints to the screen. But yeah, you should check this out. There's more stuff I want to add to it, but that's the basic idea, right? So then I said, okay, so we've got that, but now like it's useful for me to know how slow the build is, right? But I want everyone to know how slow the build is, right? So then I said, okay, well, how can I get everyone to sort of run this tool and get in the habit of sort of using it? And so that sort of came to like, well, what if we made it more general than Circle? What if we made it like sort of your gateway to doing everything with Shyp, right? So you can imagine we have repositories in a lot of different languages and a lot of different projects. What if we can provide a common sort of interface for dealing with those or managing them or whatever else? So yeah, so I added some more stuff to this, and some of my teammates added some more stuff to this, and then we packaged it into a Go binary and started to distribute it. But yeah, so this was the basic sort of genesis of the CLI. It was just like, let's go from this to like, let's help everyone figure out how slow builds are, and then let's build a bunch of other stuff in here that's useful, and then keep us up to date. So yeah, so the next question is like, how do you distribute this and keep it up to date, which is not trivial. It's easier for Go, as it's a single file versus like JavaScript or Python or anything else. But it's still not super trivial, especially in Go. Like you have to like do a release and then push a build, like build it and then like push it somewhere and then like have that host and cross compile and do all that stuff. So yeah, so this is a little out of order, but we figured out how to get it with Homebrew, right? So we set up a custom Homebrew repository, which I highly recommend if you use Macs, just because everyone on your team already has Homebrew working. So you just like tap it and then you copy whatever repos you need and you can sort of install from there. But yeah, so we just made it installable via that, right? You just brew install, it just downloads the thing and puts it on your path. Super easy. Yeah, so that's why I Go, right? It's one file. It's really fast. There's no compilation step involved. Once you have the binary, it just runs, so you can print the version string in under 10 milliseconds, which is nice. The cross-compilation tools are really good. It works on all operating systems, which is really nice. Like we could just run this in Circle if we wanted to, like in CircleCI and on SSH if we wanted to. But yeah, also I wanted to sort of introduce the team to Go. And it was a really easy way to do that without necessarily like putting the health of production at risk. If it's running on the command line and it breaks, it's okay, right? You just push a new version. Like your customers aren't affected by that. But yeah, so that was that. In terms of pushing updates, this is the trickiest part, right? Like you can download a thing one time, but then how do you get people to update it reliably and figure that out? It's tricky, right? So yeah, so we use this tool called Equinox, which is written by my friend Alan Shreve, who's sitting in the audience right now, and Kyle Conroy. They wrote a thing that just makes it really easy to sort of distribute and update Go apps. So yeah, they manage all the hosting and everything, and they manage the cross-compilation and everything for you. So yeah, so when we want to do a new release, we just check in everything, hit make release, and then there's an Equinox tool that will basically upload a new version for you. and then let you know when it's ready. And yeah, so then once that's been pushed and done, I just go into Slack and say, hey, everyone update. And then they all type in Shyp update. And then literally like 5 seconds later, everyone's on the new version, which is really nice to have something that like you can just push new updates to and then like build new functionality and push it to everyone on your team in basically under a minute, under 2 minutes is pretty cool. So yeah, so that's all I've got. Thanks very much, and I'm happy to introduce our next speaker, Miwa Jimmy Salami, who's going to be talking about creating a command.
Hi. Yeah, name is Miwa. This is kind of loud. And I work at Shyp as well, obviously. I'm on the platform team. So what I'll be talking to you guys about today is how to contribute to a tool like this and some of the things you should keep in mind when you're deciding if you want to create something like this for your engineers. Cool. So when you think about a successful command line interface, right, you want to make people be able to contribute to it, right? You want to make that very easy, and one of the ways that you do that is to try and make it modular, right? So that people can add or remove from it as easy as possible, right? And for somebody that's like just jumping into Go, like Kevin said, like Go was not something that we all knew as a team, and so having this tool and having examples of how certain commands already existed was also going to be very useful, right, if you're thinking about building something like this. And so, as you can see here, we have, you can imagine this is the Go like main file, right? And so we have an import that basically imports the GitHub concerns that we need, right? So we have Go Circle, which is essentially a repo that deals with interacting with Circle, right? So it's got stuff like Circle Wait and Circle Open. We've got Go Git, which is our repo for interacting with GitHub. And I will talk a little bit more about that later. And we also have some other tools internally called Doctor, which we use to kind of verify dev environments, right? So if you are a new developer and you want to make sure that you have the correct node version, the correct NPM version, you run Shyp Doctor and that will tell you. And Scenario is something that we'll talk about a little later today. And Tracker is something that we use to interact with Pivotal Tracker to create new tasks or complete tasks, and etc. So if you see this, like it's very easy, right? If you wanted to add something to this, you're like, hey, I should probably create a new folder or a new repo that is concerned with, if you wanted to interact with, I don't know, some other API. So that's very useful. The other thing is that we had examples, right? And so this was the main function that we have for commands, right? It's very simple. We have like a new case called help or open, and I kind of truncated this, but you can imagine just like a switch statement with specific commands that just branch off to do certain things. So this is really great for someone like me that like I have no idea how Go is like structured or how it works. I can easily say, okay, I've got these imports, right? I want to create a new tool. I can easily add a new command in here and add it to my import, and it's very easy. So when I saw this tool, I got really excited, and I was like, okay, as developers, we want to be able to like speed up our workflows, right? And one of the things that we all do on a daily basis is like create pull requests, right? So wouldn't it be cool to be able to open up a pull request from your command line, right? And there's some tools out there that can allow you to do that, but then you have to keep typing and know all the commands. But it's easier to just say, hey, Shyp PR, open up a PR, right? So it was as easy to just add a new command, right? It was just, hey, add a new case called PR and do this thing, do open PR, right? Very easy. And so our first try was this, right? And so jump into Go Git and you have this function. And this works, right? Like it opens up a PR. Like is there anything, just looking at this code, I don't know if you all know Go, but like is there anything that like jumps out to you that, hey, like that's weird? Ah, what? Oh, that's cool. Yeah, so if you notice, we are shelling out to the command line here, right? And we are depending on Hub. And if you don't know this, Hub is a GitHub tool that allows you to open up pull requests. So if you actually open up your terminal, you could type hub pull request -m on your message, right? And it would open up a pull request from your command line. That is obviously if you had Hub, right? So if you think about a tool like this, you do not, like, if we released this to anybody that didn't have Hub, or kind of created some fancy things that installed Hub on your system, that's kind of unacceptable, right? Like, people don't want you to like install extra things into their computers. That's not the way to do it. So a pro tip when you're making something like this is like, try not to make any assumptions about your user's system, right? Like, figure out how to do everything you want to do within the binary itself, right? It makes your CLI extremely portable and allows you to just like, drag and drop to anybody's system, and they can just use it very easily. So that's what we did. And one of the good things about Go and GitHub was that like all of this code was already available, right? So we went back, took a step back, and just looked at Hub and were like, hey, what is this thing actually doing? Like, can we just pull it into our own system? And yeah, that's what we did. It was very easy, right? And we just went there, reverse engineered it, and just GitHub has a new import, right? That is all the Hub commands. And in this case, we just run a lookup for the pull request. And just run that like easily, right? So we can easily, hey, there's a new release, Shyp update, you got it, you don't need to install any extra stuff, right? And so it looks like this, right? So you have like in your command line, just type Shyp PR when you're ready, and it just opens up a new pull request, right? And so again, just when and if you guys create something like this, or you're thinking about something like this, try to make it very modular so that people can just add and remove things, have some examples, and also try to do everything you can within the binary. It's going to help you a lot. And with that, I'm going to pass it to Ian Dawson, who's going to talk to you about what are our tools.
All right, so I'm a quality engineer at Shyp, and I work primarily on the mobile apps. We have 4 of them, as Dan mentioned, an iOS app, an Android app, and 2 internal apps, which means we've got a lot of stuff going on, and there's a lot of potential for super complicated states. And so one of the most exciting things for me that came out of this CLI tool was a way to generate scenarios for us to test things that might otherwise be difficult to set up. So I think I messed up here. It's actually 4 mobile apps. We also have some internal web tools as well. Let's see here. So yeah, so just a basic fundamentals of testing. You want your environment to be production-like. You want it to be stable, so if it's crashing all the time, it's going to be really difficult to test. You want your tests to be repeatable and return the same results over and over again. And you also want them to be fast, right? Slow tests don't make anybody happy. And manual testing is super repetitive, like very, very repetitive, tapping the same buttons over and over again. It's often really time-consuming to set up certain states, and the more repetitive the task, the easier it is for the person who's testing to kind of lose track of what's going on or miss really important things. So some of the things that we might have to test is, I don't know, maybe you're sending something to your friend in Italy and another thing to New York, and you have a courier that's on the way, and maybe that courier has another pickup to go to after you go pick up something for your mom, sending it to her wherever she is. In the midst of that, maybe another courier signs in, and we want to test exactly what happens in that scenario. So maybe something like this, I don't know, these bubbles meant to imply some complicated state. So one of the things that we came up with to mitigate really long setup times is our scenarios tool. Essentially, it just flashes the database that you're running locally with production code with a particular state. Maybe creates a couple of users, maybe drops something off. We have a warehouse here in SF. Maybe moves that pickup to a courier and then drops it off at the warehouse for processing later on. And so this tool hits the same endpoints that the client would otherwise. So it's doing GET requests, pull requests, post requests in exactly the same way as the client would, which is pretty good for stability. It means that we don't have any complicated database structures to set up. We let the API handle all of that for us in the way that it would in production. And the other thing is that it's really, really easy, I'll show you in just a moment, to set up new scenarios. We just have a quick JSON structure that we use to specify what endpoint this is going to hit and with what data. And we also wanted it to be fast, which is one of the reasons why Go is such a good candidate for this. So this is an example of a super simple authorization of a new user. We're going to make Herald here. We're going to hit /auth/register with a post request and maybe a little bit of data. And then we're going to save off those variables for their access token and their ID so we can use them for later on in the scenario. One of the other really nifty things about this is you can call scenarios from other scenarios. So if you have something that works to, say, add a new user, you can do multiple in a row, which is also really exciting. You know what? It's great for robots, too. Automation doesn't tend to do well with unexpected states, right? So it'll easily break. And there's also no need here for it to do its own setup, which can also lead to pretty brittle states. And it's also super time consuming. So yeah, that's the general gist of this part of our tool. And so I'm going to pass it along to Dylan to talk a little bit about web deployments with Circle at Shyp.
Hi guys, my name's Dylan. I'm leading the web team at Shyp. So I'm going to switch gears a little bit and talk about how we do kind of confident web deployments. So as you might be aware, Shyp is primarily a mobile product. We do have some important web-based pieces to the experience though. So our main one, our most visible one, is shyp.com, which is our marketing site and also contains the kind of sign up and onboarding process that we have. We also have a set of internal tools. So we have tools used by kind of customer experience agents, operations team, product team, whatever it might be. We've got a separate site for tracking pages. We've got a separate site for referral pages, and some other kind of smaller one-off pieces that you might not see as much. And all of these share a pretty similar architecture. So they've all got some JavaScript, some Sass style sheets, and usually some templates using EJS or handlebars. And some, but not all of them, have also got a server component involved. So we're doing some dynamic content or some custom routing. So what does it mean to be confident in a deployment? For us, it means a few things. So we want to be confident in the code itself before we merge it. So this means, you know, it's well tested, it's high quality, it's vetted, and we know that it does what we think it does. We also want to be confident in the build process and in the deployment process. So we want to know that the build is doing what we expect. You know, it's doing it pretty quickly. And most importantly, we want to know that it's not subject to human error. So there's no room for somebody to kind of fat finger the deployment process and mess something up. And so Circle handles a lot of this for us, which is great. So one of the best ways we can be confident in code when a pull request is opened is to know that it's well tested. So here's kind of what the testing stack looks like for our shyp.com main site. Every time a pull request is opened, we kind of run through these checks one by one. So first, we do some static analysis. We're doing ESLint and StyleLint to kind of detect common code gotchas and mistakes in our JavaScript and Sass, as well as kind of keeping the code style consistent throughout, you know, within one project and between all the projects that we have. So next up, we do a complete production build. So we resolve all the dependencies, bundle all the assets, make sure that everything is working correctly. And this is a great sanity check, you know, for the health of the project. And it also gives us a bundle that we can use later on. So we run hundreds of unit tests, both for the client-side JavaScript modules and for the server-side code. We've got some server integration tests. So we boot up a kind of ephemeral server within the Circle VM. We make requests against it. We want to make sure that things like routing, authentication, et cetera, are working correctly. And we've also got some new UI automation tests, which I'll get a bit deeper into shortly. So putting all these together with Circle is really easy. We've already got make targets and scripts to kind of handle this for local development. So all we have to do is set up our Circle YAML file to run these in sequence, and it's something like this in the end. It's really straightforward. So if everything worked, a few minutes later, we get this nice big green button on a pull request. Obviously, we still want to go through and check out the architecture of the changes, but we're confident at this point that the new code is high quality. It does what it says on the tin, and it didn't break anything else in the process. So I mentioned UI automation, which is something that we've recently been working on, and I'm personally super excited about. We've got some basic tests kind of using Selenium WebDriver and Chrome Driver. So what this does is it actually launches a running instance of Google Chrome and a small server next to it, which takes in commands and performs real actions on the web page. So this is a real browser, not a headless runtime. So we're simulating real things like clicking and scrolling and typing in the inputs and stuff. And we can use this for a couple things. We can use it to make assertions about the content of the page itself, so the right elements are in the right place and so on, as well as about the behavior. So if I want to test, I can fill in a form, submit it, get some errors, correct it, and move on. It's great to have an end-to-end test that kind of runs through all of those. And we can also use this to take screenshots of the pages at some key points in the flow. So setting up WebDriver proved to be really easy. Circle gives you Chrome driver binaries on the path. So starting up a new server using the Selenium WebDriver node module is just a few lines of code, which is great. And then I mentioned screenshots. So we wrote a little helper function to take a screenshot and persist it to disk. And so we kind of use this in quite a few places. And so here you can see another great feature that we really like about Circle. So there's an artifacts environment variable, which contains a path. And anything we write to that gets persisted after the build is complete, so we can review it afterwards. And so yeah, everything we saved appears in the artifacts tab, so we can easily click through from a pull request to review them. And so this gives us some really cool opportunities that we're looking into at the moment. So things like embedding key screenshots as comments in a pull request, or doing some visual regression testing on all these screenshots. So let's say we open a branch changing some minor details on one page, and we wanted to make sure that we didn't accidentally break things elsewhere. We could just compare historical screenshots programmatically and make sure that nothing changed when we didn't expect it to. And so the second side to being confident in our process is having confidence in the build and deployment steps. So for quite a few projects, we use Circle's built-in Heroku integration. Deployments are a one-click setup, and it's really easy to configure. For some other things, though, we have to do a little bit more work. So one example of this is a project that we want to deploy statically to S3. It's just a set of static files, and we didn't want to have to manage our own web server for this. And so for this project, what we're doing is actually setting up the S3 bucket configuration and syncing the files straight from the Circle VM. So here's kind of what our circle.yaml file looks like in the end. We add the AWS credentials into our environment variables, and then we use the AWS CLI to apply the bucket policy and configuration before every deployment. So this has been really useful for a few reasons. By keeping the configuration in source control, it's really easy to see it and change it, and we're not kind of relying on bespoke one-off configurations where somebody might have set something up slightly differently. And it also means we can add new deployments really easily. So just by adding them to this file, all we have to do is create a new bucket, and it'll be configured exactly like the others. And so another example of a custom deployment is an app that we deploy to Heroku, but which needs to compile some static assets before it can be served. So Heroku does offer a way to add a build step to your deployment, but we didn't want to use that because the build is fairly slow and it involves pulling in some private dependencies that Heroku doesn't have access to. So obviously we want our app boot times to be quick so that we can scale things up and down, add new dynos as needed, and get new versions out the door faster. And at this point, we've also already done the bundling step on Circle as part of the testing process, so there's no real reason we'd want to do it again on Heroku. So this is a simplified version of our solution. It's really, really straightforward. So when a Circle build is done, we actually create a new Git commit for it, and we push it directly to the Heroku remote. So it's fast. It uses all the same tools we were already relying on. And yeah, a lot of the local development is managed by some of the CLI tools you saw earlier. So it's really easy to push a new branch up, run the Shyp wait command, and then jump back in as soon as it's done without context switching. And we're also interested in adding some more tools to the CLI to support some of the things that are common between different projects. So, for example, we might want Shyp lint to enforce the same conventions everywhere, or maybe a tool to look back through the historical screenshots and kind of figure out when a certain issue was introduced. And yeah, so going back to the idea of confidence, we've got a great process set up at the moment where a lot of automated checks help us test new code before we merge it into the code base and deploy new code quickly and effectively. So this has helped us work faster, review code faster, and release new features to our customers faster, which is great. None of this would have been possible without Circle. We're big fans. We've been using it from the beginning, and we're relying on it more and more.
Sure. We just create a new Git branch, I guess, and then merge stuff in, and then we have 3 different realms, basically. Most of the mobile development happens in like the development realm. So that's where stuff gets merged to, and then we decide to do deployments, then it goes from there to staging, which is a copy of production, and then from there to production. It's the basic idea. Depends on the project. The API one is about 7 minutes. But yeah, it's a constant struggle to try to get that faster. I think about it a lot during these 7 minutes. So
we have API builds, and we have 4 different mobile apps. So the 2 customer-facing ones, Dav, I'm not sure how long the mobile app builds take. 8 or 9 minutes, and we just posted actually to our blog about how we do all of our mobile building on Circle, and it's pretty neat stuff, saves us a lot of time and gives us a lot of confidence. And then we also have mobile libraries that we share between different apps that build up there as well. And then, man, how many web apps do we have?
At least 5 or 6.
5 or 6. So we've got like the main Shyp.com marketing site, and then we have little micro web apps that support specific features like tracking and other things, and so we have a ton. So, and those are usually pretty quick, right? Those are
Yeah, I think
super
the longest
fast.
is Shyp.com, which has got to be, I don't know, 3 minutes at most.
That's because I wrote the original Shyp.com.
Sure. Well, we have a lot of metrics in our system that kind of tell us the health, right? So we lean on Librato, for example, and this is a tool that aggregates all of your data, and you can create really nice charts. And we funnel that into an alerting system with PagerDuty to like alert us when there are any anomalies, right? And we also have a bunch of Slack channels that get hit anytime there's a severe error on the system, so we're always watching out for that. We have a very nice on-call system where an engineer is like on call every week, and they can be pulled into such scenarios.
Also, we have couriers out in the field and technicians in our processing facilities that are amazing at hitting us up on Slack when anything doesn't work, and it's actually amazing how quickly they notice anything that's just a little bit off and will hit us. So, not the most exciting thing we always want to know first, but usually they're pretty great at calling stuff out. So we're kind of, lucky and unlucky at the same time to have them on our team. So they notice everything, which is great because they're good. So. Anything on quality?
Yeah, I mean, we also measure crash-free users and crashes in production for the mobile apps, both internal and external, and try to minimize that. I think we're at like 98%, 99 something between 99 and 100.
Very high number.
Yeah.
The pagers go off, like if there are too many crashes, Crashlytics, so that's useful.
That and we also try to minimize what we would call critical bugs in production as well.
So the React migration has been just on the website. So we we still have a very nice large Angular app that handles a lot of the kind of internal tools that operations team uses. It is large and monolithic and does not really have good hooks for test infrastructure. So as we're building things that we really want to be rock solid and confident in, we were already building some stuff greenfield in React for the website, so we kind of figured we'd build off of that. And so right now, the internal tools dashboard is a mixture of Angular and React. Different pages are running different things. So, not doing any React on mobile yet, but it's always a possibility.
Yeah, like there was an issue earlier this year, I think, where like there was like half of the country couldn't reach the other half of the country because like there was a bad BGP route or something. I don't know. And like half our apps, our New York team could not talk to our San Francisco team in Slack. And I'm pretty sure our production apps were affected. Yeah, we've really wanted to build in sort of reporting into the clients that like let us know when stuff goes bad, but just haven't got to it yet. I mean, we do have people watching basically. Like customer support tends to know pretty fast when stuff is busted, for better or worse, and our drivers tend to know when stuff is busted. Oh yeah, we run scope tests too, for some really critical stuff. But that has some false positives too. Like Cloudflare will occasionally return like a 522 to run scope, so it's not super amazingly reliable. It's like once a day that fails. So.
Yeah, we've learned a lot. When we first started picking up some of these projects, we were interested in kind of figuring out what the latest and greatest was, and kind of rolled with that for a while. But you know, we've gotten bitten a few times. There's been a whole bunch of dependencies that have updated from underneath us, and you know, left our documentation in the dust. So a big part of that is just kind of minimizing the number of dependencies you're using in the first place. We're not completely strict about that, but in a lot of cases, you know, if something has a big API surface that's breaking all the time, you know, we maybe don't need all of it, and we maybe don't need any of it. As we just discovered with some of the router stuff recently, you know, we're not leaning on stuff as hard as we needed to. So yeah, I mean, you know, there are ways, especially in the JavaScript ecosystem, to make sure that updates don't break your deployments, shrink wrap files and stuff. But at the same time, you know, if you're really on the bleeding edge of stuff, then yeah, I mean, sometimes stuff moves faster than you can keep up with, for sure.